Okay, for 30, we want to see if the series here converges or diverges, and we're going to first try it by the divergence test. So the divergence test tells us that if we take the limit of the terms with it in the series, if we take the limit and that limit is not equal to 0, your series diverges. And this is because you'll constantly be adding these terms and these terms are not 0. So necessarily your sum is constantly going to be changing. It's not going to settle down near any number. So let's take the limit. In this case, the input is k. So as k goes to infinity of k times k plus 2 over k plus 3 squared. And first we're going to expand this out. So on the top we're going to have k squared plus 2k. Oops, I forgot my limit operator. As k goes to infinity. So I'm going to expand the top. That's k squared plus 2k. And then on the bottom we're going to FOIL it out. So k plus 3 squared is going to be k squared and then plus 6k plus 9. And that's going to be the same thing as the limit as k approaches infinity. Now we're just going to divide everything by the highest power. And the highest power here is k squared. So it's going to be k squared divided by k squared is just 1. Plus 2k divided by k squared is 2 over k. All over k squared divided by k squared is 1. Plus 6k divided by k squared is 6 over k. And then plus 9 over k squared. So once we're here, we can now take this limit. The limit of 1 is just 1, so that's 1 plus 2 divided by infinity, that goes to 0, all over 1 plus 6 divided by infinity is 0, plus 9 divided by infinity, that's going to be 0. So it's just going to be 1. So we can also see here that this fails by the divergence test, right? Because the limit is not equal to 0. So the limit of actually, let me write this. The limit of the sum from k is equal to 1 to infinity of k over k plus 2, k plus 3 squared is not equal to 0, so it diverges. Diverges because it fails the divergence test. And that is it for number 30.